It's always so lovely to host you every Wednesday of the month right here at Digital Earth Africa. Greetings, leaders from the African continent and across the world. Welcome to today's live session. My name is Maud Nale. I'm the communications lead here at Digital Earth Africa, and we're honored to be hosting you today for this English live session, which is entitled The World Settlement Footprint and High Resolution Population Density Maps. And I'm equally excited to introduce today's presenter. She is no stranger here at Digital Earth Africa. She was part of the International Women's Day live session that we hosted very early on this year in March. And she's also presented on other related topics here on our live sessions. She is the Digital Earth Africa Earth Observation Data Scientist. Please join me in welcoming onto the virtual stage, Mpho Sadiki. Mpho, the virtual stage is yours. Over to you.
Thank you so much, Maud. Good day, everyone. And thank you so much once again for having me on this virtual stage. If you would just allow me to share my screen. So as Maud already introduced, I will be presenting today on the World Settlement Footprint dataset, as well as the high-resolution population density maps that we have available and you can access through the platform. So this is a topic that was actually covered already in French a few weeks ago. So today is the chance for the English version of the live session. To get started, I just thought I would reiterate what Digital Earth Africa stands for and some of the thematic areas that we focus on. This is just for those who might not know, who are joining us for the first time today, and also for those who've been with us for a long time but just need a little bit of a reminder in terms of what we stand for and what we actually do here at Digital Earth Africa. So our business is providing a routine, reliable, and operational service that uses Earth observations to deliver decision-ready products to enable policymakers, scientists in the private sector, as well as civil society, to address social, environmental, and economic changes on the continent. And to do that, we focus on 5 key or main thematic areas, which are agriculture and food security, water resources and flood risks, land degradation, urbanization, and coastal erosion. And today's live session falls under the thematic area of urbanization, as we're looking at world settlement and population data. So in terms of just introducing this topic, I would just like to highlight that the UN's Department of Economic and Social Affairs do report that 9.7 billion people will be on the planet by the year 2050. And at the moment, 55% of the world's population resides in urban areas, and by 2050 that would have increased by about 13% to 68% of the entire population. And Africa is actually the second most overpopulated continent, with sub-Saharan African cities characterized by rapid population growth. And because of this rapid and haphazard urbanization, together with problems associated with climate change, we can see an increase in things like air pollution, which can also affect people in terms of making them more susceptible to catastrophes or disasters. And this may also cause problems with the management of resources like water, raw materials, and energy. So there's obviously a need for current and reliable data, as well as tools to monitor the spatio-temporal population patterns, as well as its associated impacts. So the first data set that we're going to look at is the World Settlement Footprint and its evolution layer. So this is actually the world's most comprehensive data set on human settlement, and it was created by the European Space Agency in collaboration with the German Aerospace Center and the Google Earth Engine team. And they did so to improve the understanding of current trends in terms of global urbanization. So this data set has 3 layers. That we have available in the Digital Earth Africa platform. We have the World Settlement Footprint for 2015, which is a 10-meter resolution binary mask. So it tells you whether there is, or it tells you of an existence of a settlement footprint or an absence thereof. And it's only for 2015. And it was derived from the Sentinel-1 radar data, as well as the Landsat 8 data. And the other data set is the same thing, but for 2019. And this one was derived from Sentinel-1 and Sentinel-2 data. There's also an evolution data set that was produced from the Landsat archive, which shows you annual growth of human settlements from 1985 to 2015. So these world settlement footprint data sets offer you, or they offer a knowledge base that can help researchers, governmental organizations, and other stakeholders such as urban planners better understand how urbanization is happening and how they can then put sustainable urban development strategies for informed policies and decision-making in place. So what I'll do, I will go into the sandbox and actually show you how you can load these notebooks, or you can use these notebooks, so how you can load the data, visualize it, and then use it thereafter. So let me just stop sharing here and move over to the sandbox. But before I actually go to the sandbox, I want to highlight something very important in terms of all the data sets that we have. If you go to docs.digitalearthafrica.org, you will be able to access what we call our catalog, our data catalog, that allows you to view what data we actually have in the platform, read up some more, get some links in terms of any more explanations that you might need for those data sets. And I would just like to go through the World Settlement Footprint docs or document, which is under land and water. If you scroll to the bottom, you'll see World Settlement Footprint, and if you press more, you'll be able to see that there is actually a document that gives you the background of the data set. Also gives you a link to the Jupyter notebook that you can use within our sandbox. And you can also access through the GitHub repository. Just some specifications about the layers. This is the 2 layers I was talking about. These are the 2 footprint layers. So this excludes the evolution layer, which tells you how urbanization is happening from 1985 to 2015. So this is just the 2 layers for 2015 and 2019. We are still working on a doc for the evolution, so that will be available soon, also in the same place. So if you would like to know more about this particular data set, please go to docs.digitalearthafrica.org and you'll be able to find that there. Now back to the notebook. So this is a notebook that exists within the datasets folder of our notebook repository. So this is where we give you all the information about all the datasets that we have hosted, as well as any other external datasets that you can access through the platform. So we show you how to load them, how to visualize them, and sometimes we give some steps into doing preliminary analysis on the datasets. So if you go to the datasets folder, you'll see there's a whole lot of notebooks, but today we are focusing on the World Settlement Footprint and the World Settlement Footprint Evolution. So the first one that I'll look at is the World Settlement Footprint notebook, which will focus on those 2 layers, one for 2015 and one for 2019. So it's standard procedure. We start with the background that just gives you an idea of what this whole notebook is about. And this is a notebook that will give you a walkthrough of how to use the World Settlement Footprint 2015 and 2019 layers that we have in our data cube. So you'll be able to inspect the data set, load it using the DC load function, and also plot and do some small analysis, such as calculating the area and also creating an animation. Standard practice. So the first thing that you need to do is load the packages that you need. So these are the packages that are required for this particular notebook. And you also need to initiate a connection to the data cube, so you can actually access this data that is stored on the data cube. Another thing that you can do is look at the measurements of this data set that you want to load. So basically, you're looking at what are the variables that are included within each layer. So that's where you use the list measurements functionality to do that. And you're probably wondering, if you've never seen this data set and you don't know what it's called, you don't know that it's actually called WFS 2015, how would you actually know that? And what you need to do is go to the Explorer, the Digital Earth Africa Explorer. So if you go explorer.digitalearthafrica digitalearth.africa/products. That's where you actually be, you'll see a list of all the products that we have on our data cube. And you can see the names that you can use to access them. So if you scroll to the bottom of that Explorer window, you will see that at the bottom we have WSF 2015, and it tells you that this is the World Settlement Footprint for 2015. And we also have the WSF 2019 as well. So that is how you would know which product names to use in this particular instance. So you can see when you look at the measurements, both layers just have the one measurement, just the WSF of 2015 and the 2019. It tells you the data types, what node data is classified as well as any aliases for those data. So the next thing that you obviously need to do is determine the area that you want to look at. For this particular example, we're using Kumasi in Ghana. So you just need to specify either the latitude and the location and create a buffer around it, or if you have a shape file or a GeoJSON file, you can comment this out by putting a hash in the beginning of the code. So if you just put a hash here in the beginning, it's commented out, then you'd have to uncomment this. So remove that hash, then you can give the name of the shapefile or the path to that particular shapefile. But in this case, we don't actually have a shapefile, so we're just going to use a latitude and a longitude and then create a buffer around it. You also notice that we're also defining colors. These we're going to use for the visualizations later on. So we're saying for the 2015 layer, use a gray color and use a gold one for the 2019, but this is all up to you. You can specify it however you'd like. And of course, you can, after you've specified your area of interest, you can visualize it on an interactive map. This is the area that we have chosen, as you can see, Kumasi in Ghana. And there are other things that you also need to specify in order to use the DC load to load the layers that you want. One of the easiest things to do is to create a reusable query that you then use multiple times. So you just specify the X and the Y. These two actually tell you it specifies your location. So it will point to this particular extent that you've selected using the latitude range and the longitude range that you created in this, that you created here. So then you need to specify the resolution. So the resolution of the data set is 10 meters, hence the -10 and the 10, and an output coordinate reference system. So when you want to load the 2015 layer, you use the DC load and you specify that's the product you want and the measurement that you want within that product. And all of this information you can get from the list measurements functionality. So that is the product and that is the measurement. Those are the two things that we're actually putting in the DC load. And also the query. So this is just referring to this query that you created here. So you're saying for this location, at this resolution, with this output CRS. And you can then display it to just see that it worked. So that data is loaded. You can use that same query to then load the 2019 layer using the same idea. So the DC load, the product, the measurements, and the same query that you used for 2015. So after that, you can actually plot the data. Something very important to note with this data is that, like I said, it's a binary data set. So it has two values. It's either a 0, which means there's no data there, which means there is no settlement footprint, or it's 255, which points to the existence of settlement footprint. So if you want to plot the data, you can plot it. And because we're interested in just the settlement footprint, it's important that we filter the data to include just where there is an actual footprint. We don't want where there's no data. That's why we select where it is equal to 255, because 255 is the value for an existing settlement footprint. So that is how you do it. And then you can plot those two layers And this shows you what the footprint was in 2015, and this is what it was in 2019. So the gold and the gray colors are what we specified up there. You can choose whatever color you'd like. This is just what we've chosen for this particular example. You can take it a step further to calculate the area of the settlement footprint. So when you look at it like this, you want to know how much area on the ground does it actually cover. So this is a code that does that. First of all, you extract the size of a pixel. So the resolution, you get the one value of this value. So we just want the 10. Because it's the same, you can just square it, then it will give you the area of that cell. And we convert it to from meters to kilometers, and we get the area per pixel, so the size of the area per pixel. So if you count the number of pixels where there is a settlement footprint and multiply that by the area of each pixel, you then get the area for that year that you're looking for. So we have done that for 2015 and for 2019, and we've plotted that on a bar graph that shows you what the total area of the settlement footprint was in 2015 and what it is in 2019, and what the actual difference is, which in this case we see is an increase of about 56 square kilometers. You can also plot this change on a spatial plot, so you can see what it actually looks like. So here, what we're doing is we're trying to visualize where the change, this 56 square kilometer change has happened. Instead of just knowing that it's there, it's important that we also see where it actually happened. That's where we can see the gray is what it was in 2015, and the gold is what has been added between 2015 and 2019. But this is a static plot, so you can use some of our notebooks that tell you how to create animations to actually do this. Actually, in the next notebook where I show you the footprint evolution, we give code on how to actually create an animation. But because this is only 2 years, an animation might not be necessary, but if you'd like, you can steal the code from that notebook that I'm going to present next to add as an additional thing to the notebook to create an animation that shows the change between the 2 years. But because it's only 2 years, I think the visualization is actually sufficient. So this is the world settlement footprint, the 2015 and 2019 layers. So this is the notebook that helps you to do that. I'll then move on to the footprint evolution. As I already explained in the PowerPoint presentation earlier, the evolution tells you how the human settlement rather is changing annually, or the growth annually. So it goes from 1985 to 2015. So you also go through the same process with this notebook. You import your packages, and you connect to the data cube. But I would like to point out here, when you look at the measurements that are available within that layer, you'll see that there's actually two. There's the evolution and the IDC score. So the evolution is the actual footprint in that particular year, and the IDC score speaks to, is actually given here in this background. So the IDC score is available to provide you with a suitable and intuitive measure that accounts for the availability of the Landsat data. Remember, the evolution was created from the Landsat archive, so it ranges from 6 to 1, with 6 being that there's good availability of Landsat imagery in that area, so you can trust that this evolution was created with a good sufficient amount of data. So that's what the IDC score speaks to. So also in this area, you must specify the area of interest. In this case, we're looking at Mansoura in Egypt, and this is the area here. To just zoom in onto the interactive map. And also the same idea of creating a query where you specify the area that you want to look at using the X and Y. the resolution, and the output CRS. Then you load the data the same way you would have done with the 2015 and the 2019 layers. So then with this layer, you can plot it. And when you plot it, you can plot the evolution along with this IDC score. So you can see the level of confidence or the amount of actual data set that was available, Landsat imagery that was available to create the evolution layer. So this is the code that does that. So it does that for from 1985 to 2015. We see that the lighter colors are the earlier years, so they're closer to 1985, and the darker colors are up to 2015. And the IDC score we can see is a purple, which is a 6, which suggests there's a very good availability of Landsat imagery. So when you look at this evolution data set or this evolution plot, you can have some confidence in the fact that there was data actually available to create it from the Landsat archive. So you can also do the same thing you did with the sediment footprint, where you can calculate the total area that is covered with each year. So first we do the same thing where you get the size of the pixel converted to, and then calculate the size, the area covered in square kilometers of each pixel. Then for each year, you can use this code to then calculate the area for each year and then plot it on a time series plot like this, which would make more sense for visualization. So you can just see that from 1985, we went from less than 140 square kilometers of water sediment footprint to over 230 square kilometers in 2015. So you can just see the trajectory of the change that way. You can also just create an animation, because from 1985 to 2015 is a number of years, and maybe you just want to see how this is actually changing, not from a static plot like this. So you can actually use this code to create the animation to do that, and you'll see it's changing with each year, just adding as the footprints grew from 1985 to 2012. No, to 2015 rather. So like I said earlier, these world sediment footprint data sets are good to tell you how urbanization is happening. Then those decision makers can then put urban development strategies for informed policy decisions at both local and national levels. And I would just like to point out, you've noticed, I already said this before though, but the evolution data set goes from 1985 to 2015, while the footprint data is only available for 2015 and 2019. And this is because of the imagery that was used. So for the evolution, the Landsat archive, which goes back into the 80s, was used. So that's why it exists from 1985 to 2015, while the two layers for the world sediment footprints, 2015 and 2019, are from the Sentinel 1 and 2 for the 2019, and yeah, so from the Sentinel 1 and 2, as well as the Landsat 8 dataset, which only go back as far as 2013. So that's why that is the case. So that is it for the world sediment footprint as well as the evolution, but we're not done. There is another data set that I would like to share. So this is the high resolution population density maps and demographic estimates. So this is not a data set that we have indexed in our data cube, so we consider it an external data set, but we do have a notebook that allows you to bring it into the sandbox environment, and you can use it for any analysis along with any of the data sets that we have. So this is a data set that was created by the International Old Science Information Center and Meta, those are the Facebook people, at Columbia University. And it provides population data at approximately 30 meter spatial resolution. So it provides you with an estimate of the number of people that live within the 30 by 30 meter grid in a Landsat data set. and it combines information from sensors and building identification from high resolution satellite imagery. So it not only gives you the overall population density, but it gives you data in the following demographics, which include male, female, women of the reproductive age, children, youth, and the elderly. So I will then go back to the sandbox so I can show you this particular notebook. It will demonstrate how you can load and visualize this population data. And because this data is not indexed in our data cube, we don't actually have a docs page for it. So we'll just show the notebook, which tells you how to load this data set. So once again, it starts with the background, just giving you some information about the data. And if you want some more information, you can just click on that link and that will open to the high resolution population density maps and demographic estimates. So of course you import the packages that you need. And because this data is not in our data queue, it's hosted in AWS, you have to provide the region to be able to access the data set. I also just added this block of code to show you how you can see what is in the data set, so you can be able to call the layers appropriately. So you specify, of course, your area of interest, you can visualize it to see this is Johannesburg. And in order to load that data set, you load it using the link or the path to the AWS data that you're trying to access. So that is how you do it. So you just use the Open Rasterio package to do that, to load that data set, and you use the chunks. So using the chunks is when you're using the Dask array. So you're loading the data lazily. You don't actually load and read the data. You just load it and keep it in memory. And then as you need it for any further analysis, then it is brought in for that particular purpose. So it saves your memory in that way. And if you'd like to know more about loading data using the Dask, you can go to our frequently used, actually our beginner's guide, where we have a notebook called Parallel Processing with Dask. So if you open that, you should be able to see how you can leverage Dask to do parallel processing within the sandbox environment. So in this notebook, we're actually just showing you how you can load the data by pointing to it. And then you can plot it. And you can do that for any of the layers in there. For instance, here we're looking at youth and women between 15 and 24. So once again, you just point to the data set, load it, and plot. So that's all this notebook actually shows you to do, to just bring the data set into your sandbox environment, and you can do any subsequent analysis based on this data set. So that is all for the high resolution density maps. Also, this notebook is also available in the data sets, as are the other two that I mentioned earlier. So I'll just go back to the PowerPoint now and wrap up. So for those who are not aware, I keep mentioning the Sandbox. So the Sandbox is our cloud-based computational platform that operates through a Jupyter Lab environment, and it gives you a free compute resource that you can use to interface or explore the Digital Earth Africa data and products. So if you're not aware of it, please go to sandbox.digitalearth.africa, register, and start working with the Digital Earth Africa notebooks, as well as the datasets that we have available. And these two are links to the docs that I showed earlier, where you can see some information about any of the datasets that we have available, as well as the Explorer, where you can see the list of all the available datasets, as well as the coverage of these datasets. So that is all for me in terms of the world settlement footprint and high population density maps. But please do remember to join the Digital Earth Africa platform, sign up for the sandbox, do our master classes, which introduce you to the sandbox and to Digital Earth Africa as well, and have a look through at our videos, recorded tutorials and manuals. And all of this is self-paced and free, and you might actually get a certificate of completion for some of them upon completing these tasks. And you can learn more about Digital Earth Africa from our website, as well as subscribing to our community to receive our quarterly newsletters. And of course, these live sessions, we have them every Wednesday at 11 a.m. GMT. And if you have, you want to get in contact with us, you can also just email us at info@digitalearthafrica.org. Thank you, Maud. That is all from me for today.
Thank you so much to you, Mpho, for that very comprehensive presentation on the world settlement footprint and high-resolution population density maps, and how you can use the Digital Earth Africa platform to track urbanization. I was quite surprised to hear that Africa is the second largest populated continent. That's a lot, but we can certainly use the Digital Earth Africa platform to be able to track things like this, especially in the areas of density, world population, and urbanization. Thank you so much, Mpho, for your presentation. We never want to leave these live sessions without giving you an opportunity to connect with us. And right now, in addition to the ones that Mpho shared earlier, these are the ways that you can do so. Our website is www.digitalearthafrica.org. You can also send us an email on any topic where you're needing assistance. That email address is info@digitalearthafrica.org. A reminder about the online courses, the free self-paced online courses that we host. That website is called learn.digitalearthafrica.org. And we're also on social media. We'd love to connect with you there. We're on Twitter, LinkedIn, as well as YouTube by the same name, Digital Earth Africa. I didn't say this earlier, but today's session was in English. It is also our final live session in English for 2023. I want to take this moment to say thank you to all our facilitators who've taken their time and expertise and shared it with us during this year or during these live sessions, and most importantly to you for attending regularly and making them a great success. We wouldn't be able to host these without your active participation, but we also want to encourage you to send us topics that you believe you want to hear here. It sounds weird, but you would like to hear on these live sessions, and we'll certainly make a plan to bring those to you in 2024. We do have a session next week. It's going to be our final one for 2023. It is going to be in French. So if you speak French and you want to flex your muscle and mingle and network with the Francophone community, please do join us next week. But other than that, we do host these live sessions every single Wednesday from 11 a.m. GMT. We alternate between English and French, and I'm happy to let you know that the sessions will return in 2024, starting on the 17th of January. I want to say thank you to each and every one of you for supporting these live sessions, for sharing them with your friends and family. We're so grateful for your support. We're excited for the sessions that are going to come in 2024. So please let us know which topics you want to hear so that we can make a plan to bring those to you in the new year. It's been an absolute honor to host you today. Thank you so much for your time and your attention. Until we meet again next week, but it's going to be in French, or again on the 17th of January, 2024. Please have yourself a very good morning, a good afternoon, a good evening, and a good night, depending on where you're joining us from. Thank you and take care.